Hello, my name is Jacek and I'll be presenting the work we did at Amazon Search this year, and it was driven by our intern Azin and our collaborators from AWS and University of Hanover. To evaluate fairness of ranking with respect to demographic groups such as ethnicities or gender, we must first find a group membership of all items in the ranked list. In other words, we need to learn the sensitive attributes, also known as label, for each element. However, collecting such membership labels may be costly, operationally challenging, or even illegal in some cases. In these situations, when it's impossible to obtain the true values, sensitive labels may be inferred using machine learning models, and such labels are known as proxy labels. Unfortunately, evaluating fairness using proxy labels can lead to unreliable. Let's consider the ranking we have presented here, which is an example of job candidate search. Using a simple metric such as fractional representation in top 4 based on the real group assignments, we can see that the ranking is biased against African Americans. However, if those results were evaluated using the incorrectly predicted proxies with one error, we could decide that everything is in order and the ranking is balanced. So in this work, we'd like to address such problem of group fairness assessment of ranking based on proxy labels and see how the real bias can be recovered from proxy measurements. Let's discuss our problem setup. We are concerned with the measuring of fairness of a ranking process. We start with distribution Q over two variables S and A, where S represents the ranking scores and A is the binary sensitive attribute. Using the process, a ranking of size n is generated by sampling n independent elements from Q, getting A and S for each, and then sorting by the ranking score. Now, our goal is to reliably measure fairness of this process using some metric m, in situations when we only get to observe the proxy labels A hat instead of the true labels A for the items in the generated list. The two notions that are important is the true measurement, which is the measurement of the fairness metric using the true labels A, and the proxy measurement, which is the measurement of the same using the same fairness metrics but based on proxy labels A hat. The question is whether it's possible to recover the true measurement M having only access to the proxy measurement M hat. So in our work, we show that under certain assumptions, it is possible, in fact, to recover the linear relationship between the true and the proxy values. So under one of these assumptions, the formula became this. However, the algebra here is a little bit convoluted, so I invite the audience to attend the full talk to get more details. We evaluate the relationships that we formulate under one of these assumptions on the Goodreads authors and FIFA players dataset. And we show that the error of the proxy measurement, so the difference between the true and the proxy values, rated in pink, is much higher than the difference between the corrected measurement and the true values, which are shown in blue in these plots, which indicates that our method is applicable in the real world. So, to conclude, in this work we study the feasibility of bias estimation and ranking when proxy labels are used. We identify two feasible assumptions under each the relationship between the true and proxy measurements can be derived, and show that the relationships are true on a real-world dataset. Thank you for your attention.